our final section of this electrons unit is element group properties. And I just wanted to sort of talk a little bit about a few of the properties of the different groups. Remember, groups are called groups because everything in those groups, all the elements in those groups, behave similarly chemically. And so we can sort of talk about some of the chemical behavior of these groups. Remember, these four groups, this is alkali metals is group 1, and the alkaline metals, earth metals, is group 2, halogens is group 17, and noble gases is group 18. So we're just going to talk a little bit about a few features of these groups. The alkali metals are the most chemically reactive elements. Perhaps you've seen videos talking about, lithium being thrown into a pool of water. It explodes, it catches on fire, it's very dramatic. And that is because it's very chemically reactive. With one valence electron that it is easy to get rid of, it can easily form cations and combine with halogens to create salts. It is found in nature within compounds, but you're really not going to, because it is so reactive, it's going to react and form a compound, and you rarely find it as an element. So it's not easy to find sodium metal or lithium metal. And when you do find it, it usually has to be stored carefully in an environment so that it can't react. So, stored in a oil or kerosene to protect it, and very careful storage. Alkaline earth metals, that's group 2, are also very reactive. Not quite as reactive as the alkali metals, but still quite reactive. Their name, alkaline earth, alkaline means it forms basic. It forms a basic solution, meaning not acidic, but basic when placed in water. So maybe today you've heard, it's kind of a hip thing to get alkaline water. And those alkaline waters, if you look at them, basically they're going to have the constituents from the alkaline earth metals. So it might have calcium and magnesium levels in it. They are also, generally, you're not going to find calcium metal too much. You're not going to find it in element form very often. It's going to be much more common to find it in compounds. So we have calcium chloride or calcium sulfate. So we're going to find it in compounds, but usually not so much as an element. You can find it. It's just not, it's fairly reactive, so it's usually going to be in a compound. The halogens are also pretty reactive. They react with these metals. They react with alkali and alkaline earth metals to form salts. Also, the halogens are famous for being diatomic elements. We briefly talked about diatomic elements way at the beginning of the course when we were talking about different kinds of elements, that we had the molecular elements, which are the diatomic elements, and we have the monatomic elements. And we talked about the 7 diatomic elements, and we said that, you just need to know that there are 7 that tend to be diatomic. Well, all of the halogens are in that. And we'll talk about that in the bonding unit of why they're so favorably set up to form diatomic elements. But that's a property. And they tend to be gases. This is going to be my bromine can be found in liquid form, but iodine, bromine, fluorine, chlorine, we usually find these as gases and diatomic form. And then our noble gases are all elements in the gas state. And these are the reverse. These are the least reactive elements. And we're going to find out that's because they have 8 valence electrons. And since atoms will form ions to get 8 valence electrons, and the noble gases already have 8 valence electrons, they tend to be very unreactive. So when you want to make sure you protect something, we might use an argon, a blanket of argon gas or something around it, or nitrogen gas. It sort of blankets it because it's not going to react, and so it sort of can act as a buffer. We'll use it for a lot of those things. It's also just used when you need to pressurize something but you don't want to react. So oxygen is a great gas, but it's kind of reactive. But nitrogen, nitrogen is not a noble gas. Neon, argon, krypton are going to be good gases that are fairly inert.